In this video, we're going to do an example of a trig substitution that involves completing the square under the radical. So we're being able to asked to evaluate the integral of x squared over the square root of 3 plus 4x minus 4x squared dx. So it doesn't quite look like the form that we had before, but we can rewrite it as something that looks like constant minus variable squared. So the first thing we do is I want to complete the square with the x squared and the x piece. So we'll factor out a negative 4. So we got 3 minus 4 times the quantity x squared minus x. We're going to complete the square inside the parentheses. So we're going to divide the coefficient on the x by 2, gives us a half, and then square it. So we're going to add 1/4 in the parentheses. That 1/4 in the parentheses is subject to being multiplied by the negative 4. So that's going to give us a negative 1. So we need to add 1 to keep everything equal. Finally, we get a 4. We can add the 3 and the 1 together, so we get 4 minus 4 times the quantity of x minus 1/2 quantity squared. Well, we can factor out a 4 out of each term in that radical, and then take its square root, which is 2, so we can get a 1/2 that pulls out in front. So we've got an x squared on top, and a 1 minus the quantity x minus 1/2 quantity squared under the radical on bottom. So now we see constant minus variable squared. So we're going to let the variable piece, which in this case is x minus 1/2, be sine theta. dx, when you differentiate, the 1/2 will go away. So dx is just cosine. There's a theta missing. This should say cosine theta d theta. My apologies. That's just a typo. Just an omission. All right. So I know the radical, we're putting in sine theta for x minus 1/2. So that's where that sine squared theta is coming from. I also need to replace the x on top. Solving this for x gives me sine theta plus 1/2. So that's where the sine theta plus 1/2 is coming from in the numerator. 1 minus sine squared theta is cosine squared theta. Take the square root of it, you get cosine, and your cosines go away. So these two pieces here cancel. So we're just left with sine theta plus 1/2 quantity squared inside the integrand. We distribute, get sine squared theta plus 1/4. We replace sine squared with the appropriate power reducing formula, which is 1 minus cosine 2 theta over 2. And now do a little housekeeping. We've got a 1/2 plus 1/4, so that's going to give me 3/4. And then we get a minus 1/2 cosine 2 theta here. Now we're ready for an antiderivative. When we do an antiderivative for cosine of 2 theta, an extra 1/2 will pop out in front, so that's why we got a negative 1/4 sine of 2 theta. Antiderivative for sine is negative cosine, and antiderivative for 3/4 is just 3/4 theta. And then don't forget our plus c on the end. And then the next line is just me multiplying the 1/2 through to each term. Finally now, we need to undo the substitution. X minus 1/2 equals sine theta, so we label the opposite side with x minus 1/2 and the hypotenuse with 1. Using your Pythagorean theorem, you'll get square root of 3/4 plus x minus x squared, which is the same thing that's in our integrand here, just with a 4 factored out. We have sine and cosine that we need to replace here. Oh, I forgot to mention, we replace sine of 2 theta here with 2 sine theta cosine theta. That's why there's a sine theta cosine theta there, using that trig identity. So x minus 1/2 is sine. Root 3/4 plus x minus x squared is cosine. And so this is going to be just plugging in sine and cosine. And what we have for theta, we solve for theta, we get inverse sine of x minus 1/2. So we get a final antiderivative here of negative 1/4 times the quantity x minus 1/2 times root of 3/4 plus x minus x squared, and then minus root 3/4 plus x minus x squared, plus 3/8 of inverse sine of x minus 1/2 plus c.